Okay, just wanted to make a quick video to explain how to do this P2 sheet since I can't see you in class. All right, so on the left side I have a series of these numbers, and I want you to go through each of these sections. So I'll go through a couple examples with you. The number 41,000 kilograms. So first we're going to count the number of sig figs. In this case, the 4, 1 count, zeros don't, they're not followed by a decimal, so only 2. So 2 sig figs. Okay, scientific notation now. What I want you to do there is just rewrite this number in proper scientific notation. So we're going to move our decimal over 4 places to get between the 4 and the 1, so 4.1. We can knock off all those zeros, and we're moving it over 4. Let's keep that kilograms there because we're dealing with a number. And then in the next column, what we're going to do is look at the powers of 10 that we have, and also any prefixes, and turn those into powers of 10 as well. And at this point, it would be a good time to look at the number to see, does it round up 1 order of magnitude? Is it closer to 10, or is it closer to 1 and round down? So my note here is 4.1 is greater than the square root of 10. Remember, it's 3.16. So it will round up 1 order of magnitude. So let's take that 4.1 and turn it into a 10. And then we're going to look at 10, we'll keep that times 10 to the 4. And then kilo is 10 to the 3, just as my note says right here. So let's turn the kilo into 10 to the 3, and then we have grams as our base. Okay, so now if we look at all of these orders, remember this is like having a 1 here. So we're going to add up all those orders of magnitude, all of those powers of 10. And the order of magnitude of this measurement is 8. Okay, and actually it's not that measurement. That number with kilograms is an order of magnitude 8. All right, so let's take a look at the next one. So we have 19.3 microseconds, and if I just count that up, 3 non-zeros, well, that's nice and easy, 3 sig figs. All right, and then scientific notation. It's pretty close, but we'll move that decimal over 1 more place, 1.93. We moved it 1 to the left, so that's going to be 10 to the first power microseconds. All right, and then in terms of prefixes and powers of 10, 1.93 is closer to 1 than it is to 10. And so we'll round that down to a 1. And then we have times 10 to the first. Micro is 10 to the negative 6. So I'll turn that into that, and then carry over the seconds like this. And now we just add up the total numbers that we have up here as the powers of 10, which is a negative 5. Oh, I totally messed up my colors. Okay, so that's how that's done. You know what? Maybe I'll do one more if I can fit it in here sort of sideways a little bit. Let's go with, let's just pick this one right here, number 6. All right. I'm only counting these digits here. So 1, that 0 counts, it's in between. 3 counts, and then this 0 will count because it's to the right of a decimal. So this has 4 sig figs. And then scientific notation, it's already in scientific notation, so we'll just leave it as is, 2.030 times 10 to the 5. Oh, nanometers. Okay, and then this number is going, oh, there we go. This number is going to round down in terms of our orders of magnitude, so we'll turn it into a 1. We've got times 10 to the 5th, and then nano is times 10 to the negative 9. And then we'll just carry the meters over. And then finally, we're going to count up our powers of 10, 5, and negative 9, make negative 4. So that's the order of magnitude of that number. All right, and that's how it's done. So go ahead and try your best to fill out the rest of that sheet. And that's our first P2 sheet.